Hi everyone, welcome to this live stream webinar brought to you by CrateDB and Crosser.io. This webinar is broadcast on LinkedIn and YouTube. I'm very excited to have with me one of our partners, Crosser.io, with David in-house. Hey David, how are you doing today?
Hi, Stefan. Doing good. Thanks for having me. How are
Yeah,
you?
so I'm doing great. So very hot here in Europe, but everything is fine. So
Sure.
maybe to get started, so I'm Stefan Castellani, SVP Marketing at CrateDB. David, would you mind presenting yourself very quickly, please?
Absolutely. I'm David Inaus, Senior Solution Engineer with Crosser. Yeah, based in Germany and more than happy to be here today.
Excellent. So let's get started. Today we are going to talk about the modern data pipelines for smart factories, the value of bringing real-time analytics together with Crosser and CrateDB. So to get started, David, would you mind explaining us, how you deploy Crosser across different environments?
Yeah, sure. Um, so we thought about the best way basically to illustrate how both solutions work together and provide value to you. And we came up with this slide. I will start to explain what we do on the Crosser side, starting from the left, and then hand it over to Stefan later on the right-hand side. So with Crosser, what you do is basically you have a tool that allows you to gather information from different source of equipments, systems, from industrial environments, distributed assets, PLCs, MES systems, databases, and also cloud systems, contextualize it, bring it into a common data structure, and then push it to a system like CrateDB. The advantage here is that you can use the same tool to kind of build data pipelines from really distributed assets. And here we're talking about, for example, stone crushing machines that are somewhere in the field connected via cellular connectivity. But the same tool can also be used to connect on the factory floor to PLCs, MES systems, SCADA systems, and all sorts of systems that you find there. In addition, what we often see is the requirement to not only have industrial data available, but often to make sense out of the data and gain insights, you need access to systems that hold information like ERP related, CRM related data, historical data, connecting to quality systems, and all that stuff. So with our tool, you have something in place that allows you to connect into all of those different systems and bring the data to a centralized place. And that is where then CrateDB can show their strength. So Stefan, I think that's a good place to get over to you.
Exactly. Thank you, David. So yeah, connecting to all those different data sources is very complex, and this is really the one of the key value propositions from Cursor. And once the data is available, it needs to flow through the data pipelines, and you get different types of formats: so time series data, vector data, text data, geospatial, relational, JSON. So we see more and more disparate data formats coming through the data pipelines, and all this data can be easily stored into a single database called CrateDB, where you can put all the types of data in all different formats and easily make queries and aggregations on the fly. You can also combine your other queries and aggregations with advanced search features such as full text search, but also vector search for semantic search. And you can also easily integrate with your AI frameworks thanks to vector and similarity search. So at the end, you can use your visualization tools for analytics and BIs. You can also connect your applications to develop new innovative systems. And you can connect your AI ML platforms to CrateDB. So that's the end-to-end data flow to make things simple but very efficient. So let's move to the next slide, David. Let you introduce Crosser a little bit more details.
Yeah, absolutely. So just briefly about the company, we are a Swedish software company, headquarters in Stockholm, but we have presence in Germany as well, where I'm based. And what we offer is essentially a low-code tool that allows you to build data pipelines in a pretty easy fashion, and also offer capabilities to act on the data directly where the data derives. On a high level, we have two main components in our solution. First one, the Crosser Control Center, which you see on the top and right side. And that is the part of the tool where the user has the interface, the local interface to build, test, deploy, and manage all the pipelines. Second component, the Crosser node, is the actual runtime for these flows, these pipelines, we call it flows. We will see how it looks like in a second, but the important thing about this is the node is typically deployed as one single Docker container, and then you can fill this node with logic, with flows. So one node can run multiple flows at the same time. The interesting thing about this is that we have a clear separation between the management and orchestration, which is the control center, and then the execution, which is the node. And the node runs in your environment. And as a result, all your data, all the payload remains in your environment and is not seen by the control center. So I think that's on a high level about the setup as such. If we go to the next slide, we can see a little bit more how this looks like. So this is really just this is a screenshot from the tool as such. On the right hand side, what you see is the Flow Studio, and this is where you design, test, and deploy these data pipelines. The overall concept is that you have a library available of predefined modules, and these modules could be modules to connect into different data sources, could be industrial protocols like S7, Modbus, OPC-UA, but we can also connect into databases of all kinds, streaming services, native HTTP, and then REST API, all that stuff. In addition to that, you also have a set of modules available to do some data transformation, typically used in most of the use cases. You somehow need to extract and harmonize the data before you can actually do something with it. Then there is also modules in place to, for example, send out notifications. In case you, in the pipeline, directly detect that there is a threshold for a temperature exceeded or something, then you could also use a module that sends a message to Microsoft Teams, for example, in an easy way. All in all, this is what we offer as a solution. Obviously, there's way more details around this, like version control and deployment capabilities. But I think for a quick intro, that should be sufficient for now.
Yeah, thank you, David. And then when data flows into CrateDB, so CrateDB is a distributed database. And there are tons of databases out there, but the very specificities and the value of CrateDB that is distributed, and it brings speed, scalability, and resiliency. So whatever the volume you get, you can easily scale. The horizontal scaling is very smooth, and it's really built for very large volumes by also providing very fast ingest, sub-second queries with very low latency for indexing, and high concurrency of different workloads. When it comes to the different the storage and the different types of data, that's something we brought up earlier on. CrateDB accepts different types of data, which means it's very flexible from a storage perspective. And it indexes all the data thanks to columnar storage, which makes it very fast for aggregation. It also is based on Lucene, so it's very powerful for search. And it indexes all the fields automatically by default. And the beauty of CrateDB is that it's not just indexing a single column, it's indexing all the fields wherever they are. So for example, if you ingest some JSON data into a complex nested structure, CrateDB can index all the fields into the JSON structure. And as the format evolve and as the sensor data keep changing over time, there is no need to update your schema. You can decide to have a few fields in your database that are dynamic. And so we can adjust automatically to new fields or new structures coming from the different sensors. So based on that, CrateDB acts as a unified layer for your analytics, search, and AI projects. It can easily bring complex joins, complex aggregations in a few milliseconds. It brings also capacity for full text search and vector similarity search. And the beauty of that is that you can access the data in a very easy way. You don't need to learn any native or specific language. You can simply leverage a SQL interface to get access to all this data in the way you want. From a cost perspective, so CrateDB is an open source project, but it's also available on our cloud. We also provide some support plans. So from a pricing perspective, when you use CrateDB Cloud, it's not based on the usage you're making and number of queries you're making. It's based on the cluster size, so which is very good when you have intensive workloads and also many concurrency queries. And from a deployment perspective, It can be deployed on any type of cloud provider. It can be deployed on AWS, on Azure, on GCP. But it can also be deployed on your own cloud, on the edge, or also in a hybrid model on-premise. So CrateDB is a great storage for all your type of data. It can easily scale and can easily feed your different projects, whether it's about visualization projects, new applications, or also your AI and ML platforms. So let's dive into some interesting use cases we cover with Crosser. So David, I'm handing over to you to introduce those different use cases.
Mm-hmm. Yeah, happy to explain them. So let's just jump right into the first use case, which we see on the next slide. So what we brought to you here, Stefan, if you could move one slide ahead. Yeah, perfect. Thank you. This is actually one use case for one of our joint customers, and I just brought it to you in a visual way that you can directly see from the screenshots what we do here in our tool. So basically, in this use case, we have two type of data pipelines that have their data destination in CrateDB. The first one is getting information from different sensors in a harmonized way. So what you see in the first flow is that we read something from an S7 protocol, and we also have information coming in from OPC UA. For the OPC interface, we subscribe to data tags that we are interested in, and whenever there's a change, we generate a message that is going through this flow. And on the S7 part, we actively poll a set of data every X seconds. The good thing about this approach is we, to some degree, combine a batch approach from the S7 with a streaming approach on the OPC UA. But in the end, for the CrateDB part of things, everything looks the same. So what we are trying to build with our solution is some sort of abstraction. So in the data destination, it shouldn't really matter where the data derives from. We don't really care about the source protocol. This is all abstracted in the Crosser solution. And as part of the deployment, we also bring support for these different protocols that you see here as an example, the S7 protocol, OPC UA. And then there is another portion to this. Sorry, if you could go one slide back, I just wanted to briefly touch on the second part of this flow, which is to connect and bring data from historian systems into CrateDB as well. So a similar process, but to some degree different, since we need to restructure the data a little bit different. So here it's not connecting to industrial protocols, but to an historian system, in this case, the Aviva historian. So this is based on an interval. I think it's every 50 minutes in that use case. We fetch the historical information and send this to Crate as well, so that you then have on the CrateDB level a possibility to compare the sensor data that you just got in from the current production steps with previous data from the historian system. And this is then something that you can analyze in CrateDB quite well and detect anomalies, drifts, and exceeded thresholds and all that stuff. The next one is to some degree similar, but here we combine data from different sources directly in Crosser. So the second part, the bottom part of the flow, looks familiar to what you've seen before. But in this setup, we get even one step further and add directly production-related information to the data flow. Second part at the bottom, aggregation of sensor data, but we enrich the sensor data directly with the production order that is currently being set on the MES system. So we set up an MQTT subscription to the MES system, get the information into the memory, into a memory store, key value store, and then we combine the throughput from the sensors at the production order from the currently produced product and send the data combined into CrateDB. So it's not just pumping data from A to B, it's also combining data, enriching data. And then on CrateDB side, again, you have possibilities to run further analytics. The third use case is a bit more advanced, but also pretty interesting, and we see an increased interest in this type of use cases. We see that more and more customers leverage cameras, so vision-based inspection use cases, and this is something that you can do with Crosser as well. What you usually do is you use some sort of Python-related AI model and Python libraries to connect to cameras. Most commonly used is the OpenCV library here. The good thing about Crosser is you have a set of predefined modules, but you can also expand the functionality in the way that you bring in your own code. Your own code could be simple things like just a little bit of Python code, Iron Python code, C#, JavaScript, but you can expand this up to a point where you bring a trained AI model into the flow and deploy it with the Crosser capabilities as well down to the edge. And what we do in this specific use case is we connect to a camera stream, and this AI model is trained in a way that it can detect different objects like tables, birds, and also persons, for example. And this use case is all about detecting if a person is detected in a dangerous area for a specific time, in this case, 3 seconds. So we get the results from the AI model for every frame that it detects something. And then we use one of our modules, which is called the data trigger, to detect if that AI model has detected a person in that area for more than 3 seconds. And if that is the case, we notify someone on Microsoft Teams directly. So as part of the flow, we send out a Microsoft Teams message to notify that there is a person detected in a dangerous environment. And then at the same time, we also can send out the information as well as images, for example, up to CrateDB. And this is a nice way how you can kind of feed back and have an option, at least a starting point, to potentially retrain a model then. So the data, the results from the AI model can be sent to CrateDB directly in order to be able to retrain it, and then, potentially do some more actions on it on the CrateDB side.
Thank you, David. Yeah, thank you. So for walking through those 3 different use cases that are very different and very complementary. So now let's talk a little bit about what it means in terms of volume, because here we are talking about the functionality, what it takes to cover those different use cases. But then in the real life, it's also about scaling, about volume. And it's very important to have infrastructure in place that can cope with this this large volume of data. So when it comes to CrateDB as a database, it's a highly scalable database, and it can ingest also data extremely fast. So there are very high ingest rates. I will give a few numbers afterwards. Also, it's very well suited for very large volumes. And as the volume grows, you can make some horizontal scaling and make sure you keep the high level performance. And we are talking about milliseconds here. That's very important. Latency also need to be very low latency to index all the data across all the different fields. And we leverage columnar storage for fast analytical queries and reduce I/O when querying billions of rows. So from ingest to query, it takes about a second. The second being the time it takes to index the data by leveraging the underlying indexing systems. And when it comes to query, you can also make many different queries extremely fast as soon as the data is being indexed. And it's about making complex joins across all the index fields. And you don't need to bother about spending hours and days with your teams to define a specific indexing schema. Everything is indexed automatically, which is the beauty of CrateDB. Of course, if you don't want to, if you think there is no value, you can disable those different index across the different fields, but by default, everything is being indexed, which means that you can easily adjust to all the changing business requirements. And it's also very powerful for AI, as we're going to see in a few minutes. You can leverage your full text search capabilities. You can also make sure that you can make similarity search based on the vector embeddings for GenAI use cases. And every query is made with SQL, which makes things very easy, and there is no need to learn a new language. Also, recently, we embedded an MCP server to communicate with the different large language models. So my slide doesn't show. Is it showing on your side, David?
It's use case free. You have
Okay.
moved back, actually.
Yeah. On my side, it fully disappeared. So let me just give me 1 second just to add it back.
Yeah, you see it again.
Yeah. Okay, here we go. I'm back live.
Yeah.
So in terms of volumes, just to give you an idea of what we're talking about here. So we're working with different customers having tons of sensor data or data coming from also the different systems. And we are talking about very large volumes here. And what's very important that as the volume grows, there is no need to change the infrastructure. You just need to add a few more nodes, and you keep the very high performance as you go. It's also interesting to talk about ecosystem. While we are getting all this data from Crosser, we can also integrate with many different other solutions for visualization and AI. And so that's extremely important. And this integration is made easily thanks to the support of SQL and also the PostgreSQL protocol. So everything can be queried from CrateDB using either this PostgreSQL protocol or using an HTTP API using SQL. So when it comes to visualization, we are not providing the maps and the libraries out of the box to display that, but you can connect with very interesting systems such as Grafana or other tools. But you can very easily get access to this type of dashboard. This is a typical example of how you can leverage CrateDB with a visualization tool to easily map all the different locations of your wind farms in a wind farm mapping project. And by clicking on those different spots, you can easily get access to the underlying data. When it comes to time series data, because most of this data also is time series data, we have a bunch of out-of-the-box functions available that make it very easy to manipulate this time series data, whether it's for time extraction, time bucketing, window functions, null handling, statistical aggregates, time series optimization features, or advanced filtering and logic. And I also wanted to bring up something around AI. There are more and more AI projects out there, and it's very important also to plug CrateDB to your AI ML framework. And the beauty of CrateDB is that it's very well suited for multimodal and complex data that is constantly evolving. By managing multiple data formats, you don't need to bother about investing into different technologies. You don't need to bother about creating new silos. You can easily put your data into CrateDB and make sure it fits your AI ML models. Also, as data sources keep changing over time, it might create some kind of difficulties when you need to change your schema over time. So CrateDB offers a full schema flexibility, which means that you can get, for example, a new sensor being added to the pipeline. It might bring a new type of format, and you don't need to change your existing format. So if it's a JSON structure, you don't need to redefine a new type of format into CrateDB. It automatically adjusts by taking the new columns into account. If you want to be more restrictive, you can also do it. Everything is possible, but it gives you this flexibility if needed. And also, when you work with AI, most of the time you don't know which fields are going to be used. I mean, you have some ideas, but as your projects move along, you realize that you might need to leverage some other types of information. And real-time analytics is key, and you need to explore new types of queries and information. So by indexing all fields by default, you have this flexibility to really explore very deep and make a lot of experiments with your AI projects. So we covered quite a lot today. I think there are a few questions here we're going to share. But before getting to those questions, maybe, David, if people want to learn more about Crosser, where should they go?
Yeah. Yeah, that's a good point. So the idea with Crosser is we are following kind of an openness approach. So there's a lot of information available publicly from webinars and then case studies, but you can also get your hands dirty if you like and sign up for a free trial, which pretty neatly goes hand in hand together with the Crosser Academy. The Academy is an on-demand training that you can just go through by yourself whenever you have time. And that is really kind of the go-to place when you want to learn about the solution. But you may want to start even a step before and check out the connector library to get an understanding to what systems we are able to connect to. You can find this as well. Again, available on our webpage as well. So there's plenty of information available for you to get started. So whatever suits you best, you can just go ahead with that.
That's great. Thank you. On the CrateDB side, we also have an academy available. You simply go to cratedb.com/academy. You can also find it in the top menu of our website. And also you can sign up for a free CrateDB cloud cluster. We have a free plan forever, so you can test and play with it. And if you want to scale, it's very easy. We are hosted on different cloud providers, whether it's Azure, AWS, or GCP. So it's very easy for you to pick up your regions and your provider and to get started. So David, there are a few questions out there. So let me read a few of them. So the first one is, so what advice would you give organizations just starting their journey into edge analytics and real-time data processing?
Yeah, would you like to give it a start? Otherwise, I can just give it a start from the Crosser perspective.
Yeah, I mean, you can get started.
Good,
I
good.
can. I will probably also share some additional insights.
Absolutely. So my recommendation would be to really identify one or two use cases. Let's call them low-hanging fruits that you can use to show the value of such integrations. What I see from time to time is that customers are trying to get in kind of the big shot from the beginning, covering everything. But what we see is that is less successful, let's say. I would highly recommend to start small, pick a few use cases where you can show value. You will go through some iterations. What you do in the first shot will definitely not be the final solution. So my suggestion would be just get started small and then scale out.
Yeah, that's a
What do you
great
think?
point. No, I think I definitely agree. I mean, we need to start small, but maybe something I'd like to add is that it's not just starting small, in my opinion. It's also planning for growth. So it's starting with a solution, starting small, but you need to leverage and manipulate and learn solutions that help you scale as you need it. And planning for growth at the very beginning is important. So you can experiment, you can make some different tests, you can, as you said, you can start a very small project, but you need to make sure that the technology you're using is not a waste of time and can easily grow with you as your volume starts to, as you start to plug new data sources and grow your usage.
Mm-hmm.
Make sense?
Yeah, that's a pretty important point, I would say. If you don't mind, just one more addition to this. While you are building out the first use case, keep in mind how to scale them out, not just in regards to kind of data volume, but also in the industrial area. What we often see is that you have different plants across the globe potentially. So while building the first use cases, also think about a way how you can scale this out to your different environments that you might have. So that's an important key factor. Once you have something in place that shows value, you usually want to bring this to different environments pretty fast.
That's great. I see another question that is, that's something we hear quite often. People are wondering what's going to be the future. So let me read it to you. What does the future of industrial data and AI look like from your perspective? And how are CrateDB and Crosser preparing for it?
Yeah, that's a pretty big question, actually. But
What are
let me
your
start.
thoughts on this? Yeah, it's a big one.
Let me start from my perspective. I think, given the kind of development cadence, not just in the software area, but also in AI and so on, you need something in place that is flexible. Nowadays, what you find in industrial areas is definitely a brownfield environment, various protocols, old protocols, newer protocols, and it is important to find and to use something that kind of covers both and gives you the flexibility to expand in the future as well. So using a future-based future proven, if that is even possible, solution that gives flexibility is absolutely key. So I think here the same concept can be applied that we discussed previously. What you do in the first shot will definitely be not the final solution. But I think what we have learned over the time as well is that there's not just one solution covering everything. I think having a strong collaboration with customers and partners is key to be prepared for the future as well.
Makes sense. I have the feeling, and I'd like to get your opinion on that, David. I have the feeling that more and more people expect to leverage data more and more at the edge. I do have the feeling that people, of course, you have the central IT with everything going on, but when it comes to operational teams on the factory side, they expect to get access to data where they are at the edge without, going through the corporate systems right away. So is it also something you are seeing on your side?
Yes, absolutely. And it's not just providing easier access to data, it's also providing kind of a better understanding directly on the factory floor. It's easy to really make, let's say, data available as information somewhere on the cloud level. But currently, it's sometimes challenging to really provide, for example, the plant operators really, really good insights directly on the factory floor. And in some use cases, as we have seen previously, you just have the requirement to run the logic directly, for example, on the factory floor when it comes to visual-based inspection use case, when it comes to use cases for kind of vibration analysis, which you typically have a huge amount of data that you don't want to pump to a cloud storage first. So here, the requirement to bring more logic closer to the data source is definitely something that we see as an increasing request from customers.
Yeah, and I guess that with AI, it will get even more important to get answers to all those different questions and make some predictive analysis, I guess.
Absolutely.
There is a question more related to Crosser installation pattern. Can the Crosser node be installed on the DMZ?
Yeah, definitely. I would say that actually in many setups, the node is installed in a DMZ. So what you often find is a situation where you want to get data from OT equipment like PLCs, sensors, and all that stuff. And in many cases, this networking segment cannot access any cloud environment. So there is just no connectivity. What you can do then is to set up a node, for example, in the DMZ with two networking legs, one connecting into the OT network, getting data from these different equipments, from these different protocols, and then on the northbound side, pump the data into CrateDB, for example. So I would say this is a pretty common setup that we see a lot in our customer environments.
That's great. Yeah, also CrateDB can be deployed either in the central IT, but also it can be deployed at the edge. So both deployment patterns are available. So you showed us, your Crosser Studio, and there is a question on the customization level. So to what degree is the low-code approach customizable?
Mm-hmm. Yeah, that's a pretty good and important question. So first of all, the reason why it needs to be customizable is pretty obvious. most probably. You might be able to achieve 99% of what you want to do with these low-code predefined modules, but at some point you might want to add your own logic. So then you have different options. What I showed in this example was the usage of the Python bridge module. And that is probably the one where you can put in the most logic. You can install additional Python packages. You can bring in your custom code. You can bring in trained AI models. But sometimes it is way more simple. Sometimes you might be okay with just putting in some C# code or JavaScript code or just regular Python code. So that is something that you can do out of the box. So there is actually a third option. We hand out the SDK that we use internally to develop these modules to our customers as well. This is used when customers need to find a way to protect their IP. Let's say there is custom logic that needs to be put into a module and then used in Crosser. Then customers can build their own modules and bring them into the solution as well. So that's how customers can kind of customize the solution as such. But our approach is really to listen to the customers and requirements. So if there is the need for a specific integration towards a system that we can't cover by now, we typically discuss this together with the customer and then eventually come up with new connectors. So we really try to listen closely to customers and partners. I think that's probably the best answer I can give to this question.
Oh, thank you. Yeah, I think flexibility is key today, and having those type of flexible solutions is very important. On the CrateDB side, we leverage SQL, which makes things easier and flexible as well. And also, from an operations perspective, we try to go towards a no-ops approach, so to minimize at the maximum the level of operation skills needed to operate a cluster. So, and as you said, to be close to the customer needs, customize the solution based on their needs, I think it's really key today, and they need to get some assistance.
Yeah, absolutely. I think this kind of wraps up all the questions, right? The world today just develops so fast. You just need to get input from customers and partners in order to be able to provide good solutions nowadays.
Exactly. So I think we are pretty much at when it comes to we got a lot of interesting questions. So we are getting to a close now. I would like to say a big thank you to you, David. It was a pleasure to have you with us. I also would like to thank everybody attending this live stream webinar. It was broadcast on the different platforms. It will also be available on the different YouTube channels and also so available on the different websites. So thank you, everyone. Have a great end of your day and see you soon. Bye-bye.
Thanks. Bye-bye.